You're listening to Don't Waste Water.
And we began working with Orocobre on this, it was probably 5 or 6 years ago now. Initially through our testing facility where we demonstrated the flow scheme that they were looking to apply. And the plant is a facility that converts lithium carbonate to lithium hydroxide monohydrate. Allkem has facilities in South America that produce lithium carbonate. That lithium carbonate is shipped to Japan and through this facility is converted into battery-grade lithium hydroxide monohydrate.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
The real value that Veolia provides is the ability to understand the entire process and to be able to provide a system to, achieve the end goal from a starting brine, for example.
I'm your host, Antoine Walter, and in today's episode, I'm thrilled to welcome Jim Rieke as my guest.
It's designing and building the car manufacturing facilities, designing and building the battery plants to support those vehicles, going down a step further, designing the cathode active material plants to feed the battery plants. And then at the first part of that chain is the refineries to actually make the cathode materials, lithium, the nickel, the cobalt, manganese.
Jim is Vice President of Process Engineering at Veolia Water Technologies.
That's the benefit of these DLE systems that have been developed in recent years is all of a sudden there's much more lithium that's available in the world to be recovered in an efficient way.
Within the Veolia Galaxy, we focus today on HPD, large-scale, highly integrated process solutions utilizing evaporation, crystallization, and more. If you recall what Tony Strober shared on this microphone a couple of weeks ago,
if you ship spodumene concentrate across the ocean, you ship 6% what you want and 94% what you don't want.
6% is the highest you will get in lithium from hard rock after onset concentration from the natural 1.5 lithium content in the best spodumene. To get to the battery grade 99.95%, you hence need to refine that lithium, a quite specific and key process along the EV material supply chain in which Veolia HPD specializes, in a way Jim will explain in a minute. That said specialization doesn't stop at lithium from hard rock, though, as we'll discover with use cases from clay, direct lithium extraction, and maybe the most spectacular example with Veolia's latest reference in refining lithium from evaporation ponds. The way these projects are built is quite revealing of the pace of this sector as well, as Jim will describe how it can sometimes take up to 7 years to freeze the process design. It's also a fascinating blueprint for circular economy and resource recovery, as byproducts can be upcycled and sometimes even directly used again in the refining process. From a business perspective, it's also an interesting configuration at the edges of the traditional EPC approach, an integrator path, and sometimes a service and operation play. Want to get how a 200 headcount division of a water giant became a leading lithium refining actor? Then you're at the right place. Bear with me for some more seconds. I'd just like to remind you that if you like what you hear, my only ask is for you to share that episode with a friend, a colleague, your boss, or maybe your team. Come on, do it, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Jim. Welcome to the show.
Hey, Anton. Great to be here.
I'm looking forward to that conversation for many reasons. The first being that, Veolia is the big dog in the water industry. And I had a couple of interviews with Veolia guys, but not as much as statistically I should have within the amount of podcasts already published. So you're here to repair that mistake. And much more importantly, we are digging into a topic which sounds really fascinating. I guess it's going to be really about lithium refining, but also everything which is around that. But before going into the deep dive, let's start with the tradition on that microphone, which is to open with a postcard. What can you tell me about Plainfield, Illinois, which I would ignore by now?
Plainfield, Illinois, it's a suburb of Chicago, pretty much the furthest western suburb before you hit the cornfields that exist in the rest of Illinois. It's a kind of a small town atmosphere. It's got a little downtown area and good schools, good people, good Midwestern values. And that's where our office happens to be located.
And you've always been working from Plainfield, or did you move as well?
This area, for sure, our office moved a little bit. We had originally our office was in Naperville, Illinois, which is the suburb just north of Plainfield. We had our R&D facilities in Plainfield, and eventually we built a new office building to be next to our R&D facilities and relocated there. But yeah, for the last 30 years, I've been either in Naperville or Plainfield.
You mentioned the last 30 years. Actually, that's something really impressive in your path, is that you started as a commissioning engineer at Veolia HPD, and 30 years down the line, you're a VP, you're Director of Process Engineering and VP of Veolia Water Solutions and Technologies. What did you learn along that path?
I guess it is kind of odd in our industry and generally in the world today for folks to be at one company that long, but it's pretty common in my group. You know, we try to start our new hires in through our service and commissioning group, which is where I started. And that's really the best place to learn. Having experience in the field directly with our equipment and our clients, very steep learning curve.
What did you commission when you started?
The systems we designed and provided, mostly evaporation and crystallization systems. We're a little bit strange in the Veolia world that Veolia focuses more on water systems. I'm in the water division of Veolia Water, but our group gets a lot into production side of things, chemical, inorganic chemical production, refiners, systems of that nature. So yeah, a lot of learnings in that area. And after the commissioning process, I moved into our process design group. So actually designing the systems we provide and then transitioning into a sales group for a bit and then back to being the manager of the process design group.
Did the recent moves with the merger with Suez affect your role? Do you have a broader spectrum today, or did that change your life?
It's another set of colleagues, I think, and another set of technologies that are complementary to ours. It hasn't really affected my work too much, other than it gives us a little bit more flexibility in the systems that we can offer by integrating and collaborating with the Suez technologies, which are very complementary to Veolia's toolbox.
I have a muggle question. What does HPD stand for?
Yeah, we get that occasionally. It goes back a while. HPD was initially the Horton Process Division of Chicago Bridge and Iron.
Okay.
This was back pre-1970, and a few of the gentlemen in that company decided to split off and form their own company. So that's where HPD branched off in 1970. And we're doing similar things that we did back then, just on a broader scale. And eventually HPD was acquired through a series of acquisitions into the Veolia family.
The reason why I wanted to speak with you today is that I'm conducting a lithium deep dive on the podcast. And I started a bit looking into the various value chains, and there was one plant which popped up, which is the Naraha plant in Japan, which I saw is a plant that you've been developing and building for Toyota and Orocobre. What's the story of that plant?
The Naraha plant is something that I'm personally very proud of. It's a good success story for our company as well as Orocobre, who's now Allkem, combination of Galaxy and Orocobre formed Allkem a few years ago. The Naraha plant is a joint venture between Allkem and Toyota Tsusho Corporation. Toyota Lithium Company is TLC. They go by now, that joint venture. And we began working with Orocobre on this. It was probably 5 or 6 years ago now. Initially through our testing facility where we demonstrated the flow scheme that they were looking to apply. And the plant is a facility that converts lithium carbonate to lithium hydroxide monohydrate. Allkem has facilities in South America that produce lithium carbonate. That lithium carbonate is shipped to Japan and through this facility is converted into battery-grade lithium hydroxide monohydrate. So the entire process was developed by Veolia, our group. As I said, we then did demonstration, validation testing in our pilot facilities, which are also in Plainfield, Illinois. A lot of close collaboration with the Orocobre people. Subsequently, we entered into an engineering phase that was probably a year of feed engineering before the project was fully released. And Veolia, the large company that we are, we're fortunate to have an entity in Japan that we work closely with that has some pretty good history of constructing facilities in Japan as well. So the entire facility then was designed and constructed and commissioned as a Veolia entity.
And operated?
The operation is by TLC. the joint venture. The plant started after some delays through COVID. We were getting ready to start actually last year, and then there was an earthquake in Japan, which set us back a couple more months. But toward the end of last year, the commissioning began. There was a slight break over the holidays, and then I think we restarted early January with the commissioning process. And by mid to late February, we were operating at greater than 90% rate with on-spec battery-grade product, which is very impressive, I think.
It is.
In this industry, you see other plants that sometimes have struggled to move through the commissioning process quickly. And I think it's a good testament to TLC and certainly our commissioning group and the whole project execution team.
If I go back within that history, you said 7 years ago you started working on the project. Allkem, at the time, Orocobre comes to you and say, I have this brine in South America, which gets then refined up to lithium chloride, then lithium carbonate. I want to convert that to hydroxide so that take it to your plain field facility. What is it that you have to test in your lab? And what is the treatment train which you end up building?
Sure. Yeah, our lab is a really key tool in our design effort in a lot of these flow schemes that can be somewhat unique. Usually we'll conceptualize the process flow scheme in my group, the process design group, and much of the unit operations that we use are fairly well known. The thing that is always unique is the actual chemistry of the lithium carbonate that Orocobre was producing, for example, the expected quality of the lime that's used in that process. So the testing facility allows us to validate the process design that's conceptualized and just make sure that the chemistry behaves exactly as we've anticipated. And very important in the battery materials industry is the ability to produce, obviously, the high purity product. So being able to understand how the impurities distribute through the system as you're concentrating and purifying is very important. And that's something we're able to do in the lab, is very accurately flow sheet the chemistry and validate the process design. So we know that when we actually build the facility and commission it, that we'll be able to achieve the purities required.
What's this process? What do you have as steps which bring you from carbonate to hydroxide?
So there's a number of steps. The main overall process is using lime to convert the lithium carbonate to lithium hydroxide. So the hydroxide ion is provided by the lime. Through the reaction with lithium carbonate, the lithium carbonate is reacted to lithium hydroxide with a byproduct of calcium carbonate. So through the exchange of those ions, the calcium carbonate is filtered, removed, and then you end up with a weak lithium hydroxide stream that also contains some of the impurities that entered with the lithium carbonate and with the lime that was used for the reaction. That stream is further purified through ion exchange, and then through an evaporative process, it's concentrated, and through a series of crystallizations of lithium hydroxide, the impurities are removed from the lithium hydroxide. The lithium hydroxide is then dewatered and dried and bagged as a final battery-grade product.
If I'm right, the downstream portion of what you just described is the core of what HPD does. So the evaporator, the crystallizer, probably also the dewatering. The first steps, so the ion exchanger, the chemical dosing of lime, is it also core technology from Veolia, or is it stuff that you source with partners?
It's a combination of both. The reaction system, the clarification, it's something that our division is very familiar with, and we designed those components. But, it's technology that can be procured separately from third parties. Certainly the centrifuges, the drying equipment are procured from third parties and integrated into the system. But we're very familiar with designing and integrating overall processes. As you said, the main core technology for my group is evaporation and crystallization, but we integrate those peripherals so that we can provide a system with a process guarantee around the entire plant.
So that's one route to get to lithium hydroxide, which is this brine evaporation, and then you come with the refining. There's another route which is currently developed. I'm not sure if there's already a full scale of it, but it is to extract lithium from clays. And if I'm right, you have a project in the Rhyolite Ridge, so in Nevada, with Ioneer. Where are you in that project? And is it comparable to what we just described, starting with carbonate out of brine?
Correct. Yeah. We've been working with Ioneer for a few years now. Lithium from clay has its own challenges. It's a unique flow scheme. And again, the key is to concentrate the lithium and separate the impurities that are in the feedstock. So with clays, you're starting with their particular deposit. There's an acid digestion process to remove the lithium and other compounds from the clay. And then that particular deposit also contains boric acid, which Ioneer is intending to recover as a byproduct. through a series of purification, evaporation, and crystallization steps, the lithium is concentrated in a brine, separated from the impurities, and then a lithium carbonate precipitant is then removed from the brine and further purified to become a battery-grade product. Where we're at with that project is we've currently done a testing and a pretty good amount of engineering, so it's still in the engineering phase at this point.
When would you expect it to become commercial?
I'm not sure exactly the expected commercialization date. There's still probably a couple of years between the additional engineering and the construction process before it's started up.
So let's take another route, which is, dare I say, the conventional route to lithium, which is to start with spodumene or lepidolite, whatever is in rocks, and then to refine that up to battery grade, be it carbonate or hydroxide. I was told that you were in Australia not so long ago, and Australia is known to be the place where we extract the spodumene and then we go down that route.
Correct.
Does that have a link? Do I have to expect Veolia to have references and projects ongoing in spodumene? Do you already have some?
Yeah, we're currently in the, execution phase of one of those projects in Western Australia. There's several companies that have built or are building refineries in that part of the world from spodumene, where there's, historically in Western Australia, there's been spodumene deposits that have been exploited. A lot of that spodumene is currently processed in China, but in recent years, the spodumene is intended to be processed locally and refined into lithium hydroxide. So Albemarle, Tianqi, and Covalent all have spodumene refineries in various states of construction and commissioning in Western Australia.
And Allkem just commissioned one. I'm just wondering, because you've been working with Allkem in Naraha, so I was thinking maybe in Perth you might be also involved.
I don't know that Allkem has a spodumene facility in Western Australia. I know they're looking at some in Canada, which is another area where there's spodumene deposits. But the company we've been working with in Western Australia for spodumene is Covalent Lithium.
How different is the process from spodumene compared to what we just discussed, starting from evaporation ponds?
Spodumene, as you said, it's an ore with a couple of % of lithium oxide concentration. That spodumene conventionally is upgraded to maybe 6% as a solid through a benefaction process before it's shipped to a refinery, just to minimize the amount of mass that has to be shipped. But then the refining process involves crushing and calcining to convert the lithium to a form that's leachable. And then there's an acid roasting process where the lithium is basically roasted and leached from the ore to form a lithium sulfate brine. That lithium sulfate brine is then, through a series of purification steps, purified and concentrated evaporatively. That's where we get involved. And then after the evaporation process, when it achieves a certain concentration, it's causticized to convert the lithium sulfate to lithium hydroxide. Usually that's through the addition of sodium hydroxide. The lithium sulfate sodium hydroxide reaction results in lithium hydroxide and sodium sulfate. Sodium sulfate becomes a main impurity that's removed with a crystallization process. The remaining lithium hydroxide is then crystallized a couple of times to achieve the desired purity. So it's a little different than the other process, except the very end where lithium hydroxide is crystallized for that last purification.
You gave some keywords like evaporation and crystallization, which call for probably your proprietary technologies. How do you address that market? Like an OEM providing your evaporators and crystallizers, or as an EPC saying whatever starts from roasting up to the final dewatering can be done by us as an EPC? The
real value that Veolia provides is the ability to understand the entire process and to be able to provide a system to, achieve the end goal from a starting brine, for example. So we're able to provide all of the unit operations in order to achieve that technical goal and provide a process guarantee around that whole system. From a EPC standpoint, the construction side of things, that's not where Veolia's value lies, although we have in the past taken on EPC responsibility. That's rather unusual. Our core value add is the system design and the supply of proprietary equipment that allows us to achieve that technical objective.
If I dare ask, who's living in that space with you? Let me try to name drop some. Coke, would that be the other big fish in that pond?
Yeah, Coke is somewhat involved in the lithium industry, but they're more involved with the EPC side and some of the technologies, but not as an extensive portfolio of technologies as Veolia.
So you would rather be working with them than be competitors?
Yeah, and in some cases we are in the industry. We're somewhat complementary to each other.
I'm trying to wrap my head around it. When I interviewed Ben Sparrow from Saltworks, he named spontaneously Veolia as the big dog.
We absolutely do have competitors. There's a certain very large and reputable company out of France.
Okay, so the Reds.
Yes. Yeah. And they equally, like us, practice industrial desalination. And with that, they're a leader in CRC and lithium.
So I guess Saltworks is your competitor as well?
Saltworks more is focused on, I think, the process technologies, evaporation and crystallization. So they play maybe closer in the space that we do, but they're somewhat smaller company. And again, I don't think they have the range of technologies that Veolia does. That's really what differentiates Veolia, is that we're not only the big dog, as Saltworks said, in evaporation and crystallization and in the lithium world, but also the ability to just provide almost any unit operation required and integrate those all together to offer a system.
The reason why I'm asking is when I discussed with several consultants, what they told me is that the bottleneck in that road, that PowerPoint road 2030, where we can maybe meet the lithium demand with some additional supply, the bottleneck might be on the refining part. And what some told me is that the order books are quite full in the companies like yours, which means that also the lead times will at some point get longer, and it might become a challenge to deliver all of these plants worldwide. Does that depict your reality?
The challenge is quite large for the industry. You've seen the amount of incentives that are being provided by various government entities and the announcements from almost all the automobile manufacturers that are planning to build EVs and have actually committed to a certain number of EVs by 2030 or 2035. So there's going to be a huge demand, and there's a whole value chain that's required to support that vehicle production. So it's designing and building the car manufacturing facilities, designing and building the battery plants to support those vehicles, and going down a step further, designing the cathode active material plants to feed the battery plants. And then at the first part of that chain is the refineries to actually make the cathode materials, lithium, the nickel, the cobalt, manganese. So I think, it's hard to see where the bottleneck might be, but there's a very large challenge to all of those pieces of the value chain or the supply chain have to converge and be operational at the right time in order to achieve the end goal. And certainly building and commissioning and operating a refinery is going to be part of that algebra, I would say, to meet the supply needs. And the supply chain for the refineries includes, not only the engineering and supply of the systems, the work that my company does, but also the subcomponents that go into those plants, the centrifuges, the compressors, the dryers. I think it will be a challenge to do all of that efficiently.
So what you're saying is that it's not one critical path with one bottleneck, but it's a succession of different critical paths and potentially more than one bottleneck. So you have to really plan that out thoughtfully.
Very much so. And you see the car manufacturers on the end of that chain getting very involved in each step through investments, through equity positions, through offtake agreements. I guess to say again, that the algebra of that calculation is very complex, and the planning required to make sure there are no bottlenecks, so all of that supply lines up properly.
There are two more routes to lithium. One where I'm pretty sure you are involved, and one where, if I'm right, you're not involved. Those two additional routes would be lithium recycling, and there I think you already have active stuff ongoing. And the other would be direct lithium extraction, where I didn't see you having a footprint there. Is it right already? And then maybe if we start with recycling, what do you do in that field?
Veolia has been involved with recycling. Veolia does have battery recycling plants, and they are looking to further move up the value chain with those by not just recycling batteries, but also purifying the black mass that results and actually producing materials that can be reused as cathode materials.
So does that mean that Veolia HPD is acting as a service provider to Veolia Waste and hence upgrading the plants so that you can extract valuable materials from the black mass?
That's the intention. We haven't gotten to that point yet with Veolia, but Veolia HPD is active with other battery recyclers doing exactly that.
Li-Cycle?
Li-Cycle, for example, exactly. We've supplied evaporation and crystallization equipment to be installed in one of their hubs, and that plant is currently under construction.
So that's one more route. And what about the DLE route?
The DLE route, Veolia and Veolia HPD group, we don't have our own DLE technology, but there are many companies out there that are developing such technology, and we are involved with projects where we would be engineering and supplying the equipment downstream of the DLE to take the upgraded lithium eluate that comes from those systems and further concentrate that, purify it, and crystallize either lithium carbonate or lithium hydroxide from that stream.
So you would be a post-treatment to DLE operators, which enable them to go to battery grade.
Correct.
You mentioned that you don't have in-house technology for that, yet Suez WTS, so the portion of Suez which is now part of Veolia, used to be active with their membrane division, and in several projects across them in South America at least.
Mm-hmm.
Does that mean that it might become part of your lithium portfolio at some point?
It could be. I mentioned that earlier that Suez and Veolia have a lot of complementary technologies, and certainly the former Suez group was very strong in the membrane area. So you see a lot of these flow schemes require or utilize membranes for that initial concentration of the lithium once it's recovered from whatever resource is feeding the facility. You could see DLE becoming part of our portfolio, but it most likely, just because it's very specialized and sometimes specific to a certain feed brine, most likely will be a third-party unit operation that's integrated into a Veolia facility or a Veolia design, and we would just provide a system that included that as a piece, but likely procured from a third party.
So, I have this backstory project, which is a bit the start of my lithium deep dive, which is that just next to the home I grew up, there is a source of lithium. I make you really the short version of that story. In those brines, there is 300 to 400 ppm of lithium. And so I was wondering who would be the right people to address if I was to say I want to switch gears and I stop my podcast thing and I go really into lithium extraction. So if I get you right, I would need to look for a DLE company, and you might be able then to supply me with the refining step.
Correct. Yeah, 300 or 400 ppm lithium without a DLE technology, it would be probably uneconomical to try to recover that. But that's the benefit of these DLE systems that have been developed in recent years is all of a sudden there's much more lithium that's available in the world to be recovered in an efficient way. So yeah, that would be the likely path for you to develop your 400 ppm lithium source, is find a DLE provider that has a demonstrated technology. They would probably do a little demonstration plant to show that can be concentrated to say 2,000 or 3,000, 4,000 ppm through their technology. And the DLE technology usually not only concentrates the lithium, but it also purifies it during that step. And then once that brine is concentrated and purified a bit, that's where Veolia could take over, and through the more conventional unit operations that we have in our toolbox, put together a system that further concentrates, purifies, and ultimately would crystallize and produce either lithium carbonate or lithium hydroxide.
As you mentioned, this new development of DLE opens many new sources of lithium, which is great on one end, but if you're a developer like me, in that example, it means a lot of competition, which also means I have to be fast to market. So if I want to secure that you can deliver me my refining step, how early do I have to place a bid, and what is the timeline between the moment where we sign an agreement that you will refine my lithium and the moment where it is commercially producing lithium in southern Alsace?
I would say the first thing that we always want to achieve is design freeze, a process design freeze. So you'll see in a lot of these projects that we've been involved with, it takes 6 or 7 years from the time we first make contact with the client to that commissioning process. But a large part of that often is doing the design work, testing that allows you to validate a flow sheet and achieve design freeze. Once you have a frozen design, then you can move that process into the detailed engineering phase, which then leads to procurement and construction. So from process design freeze through construction to commissioning, that lead time is maybe 2.5 years, I would say, as a typical. And I think as we, through the industry, have more learnings on the different flow sheets that are available to move a certain brine or a certain clay or a certain hard rock, a lithium hydroxide or a carbonate product, the more experience the industry has the quicker we can achieve that process design freeze.
So that is one aspect of the story. The other aspect of the story is that if you can extract as much value as possible along the process, you probably shall do it. And you mentioned how there's one byproduct, which is calcium hydroxide. Are there more byproducts along the refining value chain? And how do you valorize those byproducts and how do you extract them?
Correct. Yeah. In these processes, there's usually some byproducts just due to the chemical reagents that you use in order to convert the lithium to the final form that you wish to use, whether it's lithium hydroxide or lithium carbonate. The byproducts that result, for example, in the Naraha plant, one of the byproducts is calcium carbonate. Calcium carbonate it's lime mud, essentially. Normally it doesn't have a lot of value. One of the unique things about the Naraha plant, though, that, again, I think is something that could be applied elsewhere, and it fits into Veolia's corporate mission, is recovering that and recycling that. So at the Naraha plant, the calcium carbonate is recalcined through a lime kiln and converted back into active lime that can then be used at the front of the process. That's one way, or one byproduct, and one way to valorize that byproduct. In the spodumene path that we discussed, a byproduct of that process is sodium sulfate. Sodium sulfate it's a commodity chemical that's used around the world, a lot of it in the detergent industry for solid detergents. So there is a use for that, but with more and more of these refineries that are coming online, there will be more and more sodium sulfate to utilize, and the existing marketplace might be stressed. So there's various processes as well that Veolia has to valorize sodium sulfate, one of which is a conversion of sodium sulfate to potassium sulfate, which is a specialty fertilizer, which is quite beneficial compared to other fertilizers in that it's low in chloride, so it's better for the environment than conventional potassium chloride fertilizers. So that's one path of valorization of sodium sulfate. And then Veolia also has a technology that converts the sodium sulfate back into sodium hydroxide and sulfuric acid so that it can be recycled directly into the plant and offset fresh makeup of those chemicals.
You just mentioned several technologies which you have in-house. So I'm wondering, if now I take my business hat, what is the special sauce of Veolia? Is it this constellation of technologies that really you can address whatever subpart of the process you're going to have, whether something in-house or the know-how to take a third party? Is it the process guarantee you mentioned a bit earlier in the conversation? Is it your ability to deal with complex and large projects? If you have to name just one special sauce, what would it be?
Oh, that's hard because it really is a combination of things.
Let's go for the combination.
Let's go for the combination then. Yeah, I think firstly we have, very smart people that work at Veolia with a wide range of experience in the chemical processing industries. So we are able to put together these rather complex processes that, often are first of a kind or have very unique feedstocks. And then we have the unit operations in our toolbox that we understand very well. So we're able to put those systems together and optimize those, and as well as having the testing facilities to validate those systems and provide process guarantees. And then we're a large enough company as well as Veolia to be able to provide those systems that are often $40, $50 million systems. We can provide them on a global basis with the full backing of Veolia process and mechanical guarantees, which is very comforting to our clients, especially some of these players in the battery markets, for example, are smaller companies. So being able to get those projects financed is a lot more feasible when you have someone like Veolia providing the process design. And then, the capability to do that and look at all the systems holistically, like at the Naraha plant, as opposed to having a separate third party, maybe an EPC that doesn't understand the technology, have to put all of those unit operations together. It just allows us to provide a more holistic offering and to control the risk a lot better for ourselves and for our clients.
Let me try to see if I get that special sauce. So you have people dealing with complexity. That's one first element. You have the tools in the toolbox. You have the testing capability, which enables you to then take process guarantees. And then you're large, which means that you can be really everywhere worldwide, which makes it easier to finance a project. And your engineering in-house gives you a holistic approach.
It's a pretty good summary. Yeah. Thank you.
You mentioned the testing. Does that mean that every project has to come to plain field at some point? Or do you also use the full Veolia network to tap into other facilities?
We do use the Veolia network to tap into other facilities, and whether it's, we have a very strong technical and development group based in Paris that we interface quite a bit with. And now we have the former Suez company also has very strong testing capabilities, more on the membrane side that we're collaborating with. But yeah, when we're doing complex flow sheet development, most of that for the battery market industry is in plain field, but not all of that has to be tested. It's only when there's a gap in our understanding or a special chemistry that we're not familiar with that we'll want to do some validation testing.
What is the size of Veolia HPD today?
Our group is about 200 people. There's about 150 located in the Plainfield office, and we have another satellite office in Bilbao, Spain that has similar capabilities, but we collaborate very closely, and they just geographically are better able to serve the European area.
And what would be the turnover of that business unit of 200 people?
The turnover is, 150 to 200 million per year.
That makes for a good tour of your world at Veolia HPD. So really thank you for the openness, and you didn't push me back on any of my tricky questions, even when I tried to figure out what you were doing in Australia, which maybe was secret. Apparently, hopefully not.
No, Australia, there's so much going on, and there always has been in the mining industry, especially in Perth. It's like a center of mining activities. So a number of things happening out there, a number of potential clients, and we've had a big presence there for many years.
Well, thanks for that deep dive. If that's fine for you, I propose you to switch to the last section, which is the rapid fire questions.
Okay.
It's time for the rapid fire questions.
So in that section, I try to keep the questions short, and you are supposed to keep the answers short, but you can also take more time. I'm never cutting the microphone, and you'll notice that the one which is always sidetracking is me. My first question is, what is the most exciting project you've been working on, and why?
Yeah, I think we've covered this. The most exciting project has been the Naraha plant, just because it's the most recent one that started, and the commissioning went so well. I think it's a great story for the industry, how quickly it started. I'll say there's a close second. We're working with Energy Source on a project in California, which is a DLE project that's removing lithium from geothermal brine. And Veolia would be providing all the downstream equipment there, as well as for that particular facility, operating the facility. So that hope will be commissioned in a couple of years. So we're just moving into the construction process, hopefully soon.
California, is that the Salton Sea or is it another project?
The Salton Sea, yes, correct.
Okay. I heard that's the most tricky one, and you solved it.
Yeah, the tricky part, I think, is managing the geothermal brine, which has very high temperature. It has some scaling compounds. The good thing about that facility is Energy Source actually operates and has operated that plant for a while and knows very well the characteristics of that brine. And they've developed their own DLE technology, which is, they have a long period of demonstration on that particular brine with their technology. So I think it's after you get through the DLE, the downstream part is more conventional equipment that Veolia is very good at providing.
I warned you about the sidetrack, so...
Hey, I know, sorry. And I'll talk a lot too, and so we can get ourselves into trouble.
I have one more in the sidetrack, which is, you mentioned Canada, and there's this mining area around Quebec and basically not so far from Plainfield. Is that something you're looking into?
Yes, yeah, it is. We have a couple of clients up in that area as well, and that we're in various stages of the project with for spodumene conversion from those facilities. And that Bécancour area up near Montreal is very active, not only with refining, but also CAM, PCAM. And again, that's, I think, the Quebec government trying to incentivize that sort of activity.
Sorry for the sidetrack. Let's go back to the main track. Can you name one thing that you've learned the hard way?
Through my career, the things that are the big learnings are the hard learnings, the ones that may be a little bit painful. And these often happen during commissioning process. But I guess one key learning is that it's usually not the things that you're worried about that trip you up in these complex flow schemes. Sometimes they're rather simple things that cause the most delay or heartache. So it's really kind of makes you focus on being very thorough on all aspects of these projects and not just the ones that seem to be the most tricky.
I think that's a very valuable one. Thank you. Is there something you are doing today in your job that you will not be doing in 10 years?
That's a good question. Probably, maybe I won't be typing as much, I think, with the advances in technology. But otherwise, I don't know that my job's going to change too much in the next 10 years. And I think that's what I like about it. There's a lot of variety. And with chemical engineering and, building these refineries, it's basic principles and The equipment will be similar. Maybe the technology that allows us to do the engineering more efficiently or communicate more efficiently will be different. But I think more or less I'll be doing mostly the same things.
What is the trend to watch out for, be it in HPD's core sector or in the water sector, more broadly speaking?
Trend to watch out for? I think you'll see more focus on recycle and recovery of these byproducts. I think that will become a more evident thing that needs to be addressed as some of these plants start to be commissioned, and those byproducts need to be valorized somehow or disposed of. And the trend, I think, will be to vary with a lot of focus to try to avoid disposal and to instead find a way to recycle or reuse.
I really want to prevent starting a new sidetrack here, but it's a fascinating one, which we've discussed several times on that microphone, because having the technology to recover a byproduct is one thing, but you need to create the value chain and to have a full system in place so that once you've recovered something, be it the ones you mentioned, like potassium sulfate or sodium hydroxide, that then you can really bring them along that path. And I guess that's the thing we have to build going forward if we want to go into this circularity.
Yeah, correct. It's another one of these challenges where there's some algebra to be done on how to make it all work in an economic fashion. But the drivers will be there, I think. And I think society will demand it as well. So, it'll be a combination of the refiners, the battery manufacturers, the car companies all will have to make that a priority and to find those, I guess, the path to market to reutilize those byproducts.
Last question. Would you have someone to recommend me that I should definitely invite on that microphone as soon as possible?
Boy, that's a tough one. I would try to get maybe someone from one of the higher up the value chain, one of the people from one of the car companies perhaps would be interesting, I think, to see how they see the marketplace and their activities through that value chain that we discussed previously and how they're involved throughout those steps.
I've sent a tweet to Elon Musk, but he wasn't available.
That would be a key. Yeah, if you could get him on the show, that would be great.
Actually, all jokes aside, I just looked at the valuation of several lithium companies, and you have a couple of them which are valued at roughly the same amount than Twitter. And would I have been in his shoes, I would rather have bought one of these companies than Twitter, but I'm no one to, and I'm certainly not in his shoes. So yeah.
Well, it's funny you mentioned him. If you have an opportunity, they just, I guess, published their Master Plan 3, which I think Tesla does occasionally. They'll talk about not short-term goals, but some of the longer-term objectives. And I think Tesla does plan to be more involved in that supply chain as a producer of EV cars, wanting to make sure that they have a secure supply of cathode materials. I think they're very focused on that side of the business. So that would be a fascinating discussion. But I think all the other car companies are thinking similarly, just in order to secure the commitments that they've made 5-10 years from now to produce those cars.
Makes sense. Well, Jim, it's been a pleasure to spend that hour with you. If people want to follow up with you, where shall I redirect them the best?
Yeah, they can contact me on LinkedIn or through email at jim.rieke@veolia.com.
I'll put the links to both your email and your LinkedIn profile in the show notes. So if you're listening to that, just go have a look at the show notes and you'll find everything there. Well, thanks a lot for your time. And I hope to get to speak to you again in the future when you commission your first DLE refining plant, because that might be the reference I have to visit for my own project.
That would be great.
Thanks a lot.
It's been my pleasure.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.